Okay, class, today I want to continue our discussion on functions dealing with proportional or non-proportional functions. Okay, so the standard that we're looking at right now, it says we're going to distinguish between proportional and non-proportional situations using tables, graphs, and equations in the form of y is equal to kx or y is equal to mx plus b, where b is not equal to 0. Well, I want you to notice something in this particular standard. Y is equal to kx. This is something new. We haven't talked about this. Now, in 7th grade math, we do talk about this k being what we call a constant of proportionality. But because you've skipped 7th grade math, we don't quite understand what that means. So, throughout this lesson, at some point, we're going to determine what k means and why we've got a k here, kx, versus mx. Okay? So, I'd first like you to do a couple warm-up questions. So, here they are. In the first two, this one right here, I'd like for you to tell me what is the slope and y-intercept of each of these equations. In this second problem, I'd like for you to find the slope and y-intercept and write the equation of the t-chart that I'm giving you. And then in number 3, I would like for you to evaluate this function, f of x, for the value of 10. Okay? And then if f of x is equal to negative 14 or 1,465, what value of x could I put in this value right here, in this spot right here, to make this function equal negative 1465? So pause the video and answer those questions for me. Okay, let's see how you did. Let's look at the first one. Okay, in this first question, I asked you to find the slope and y-intercept. So I'm going to start with this second one right here, because it's one that we're familiar with. Now we know that in our typical formula that we use is y is equal to mx plus b, where the m stands for slope and the b stands for y-intercept. Well, if you'll notice, I flipped these around, okay? But our slope is always going to be the value that is with our letter, with our x. So that means our slope in this problem is going to be 13. And our y-intercept is going to be the number that's by itself. So the y-intercept is going to be 5. So when we look at this other one here, thinking about it, okay, what is our slope going to be? Well, I don't have a number that has an x with it, so let's come back to the slope. We'll think about that one in a second. Okay, now what about our y-intercept? Well, I know our y-intercept is going to be, in this problem over here, it was the one that was by itself. Well, that's all I have right here is the 6 that's by itself. So believe it or not, the 6 is the y-intercept. Okay, and the slope is actually going to be 0. Okay, because there's not a number with a letter. So if I were to have 0x and I put that into the equation as 0x plus 6, it's not going to matter what number I plug into x, I'm still going to get a 0 for an answer. So this one gives me a slope of 0. Now what do you think that would look like on a graph? Well, let's see. Let's take our calculator and let's find out what it would look like. Okay, so let me reset my calculator real quick. I want to make sure my y equals is empty. Okay, I'm going to come to zoom, and I want this zoom to be zoom 6, just zoom standard. Okay, uh-oh, I do have something on my graph here. Let me go turn that off real quick. Okay, sorry about that. So now, we're going to go into y equals, and we're going to put the number 6 there. Okay, so this says that the y-intercept is going to be 6 and it has a slope of 0. So what is that going to look like? Well, it's a straight line across. It's a line that has absolutely no slope. So it's just a straight, flat line at y-intercept of 6. Okay? And that's what that one's going to look like. All right? So it's kind of interesting to see that. So now, let's look at the next question. On this one, I asked you to find the slope and y-intercept of the t-chart. Okay, well, we always go for the y-intercept first. Okay, because I know the y-intercept is going to be the y value when x is 0. So it's going to be this 12 right here. Okay, so 12. Now I need to find the slope. Now to find the slope of a t-chart, we know we do delta y, or the pattern on the right-hand side, which in this case is negative 4, divided by the pattern on the left, which is 2. Okay, so that means our slope is negative 4 over 2, which simplifies to negative 2. So if I want you to write the equation of this line, it's going to be y equals blank x plus blank. Well, the number that goes with the x is going to be our slope, which is this one right here, negative 2. That is our m value. Okay? Now, to find our y-intercept, we did that already. It was the y value in x is 0, so it is 12. So this is the equation of the line that matches this t-chart. Okay? And then the last one that I had you do was I had you evaluate an expression. So this one says f of x is equal to negative 98x plus 5. What is this evaluated for f of 10? So I'm going to take the 10 and just plug it into the x. So this becomes negative 98 times 10 plus positive 5. So negative 98 and 10 gives me negative 980. So negative 980 plus a positive 5 gives me negative 975. Now if I said f of x is equal to negative 1465, as we did in a previous lesson, we're just going to take this value right here, the negative 1465, and substitute that in for f of x. So negative 1465 is equal to negative 98x plus 5. And now what we have to do is just solve for x. So I have to get rid of the 5 first by adding a negative 5, and I do that to both sides. Okay, we add these two negative numbers together to get negative 1470 is equal to negative 98 over x. Now to get rid of the multiply by negative 98, I divide by negative 98 on both sides, and you end up with x is equal to, and when you do the math here, you end up with 15. Okay, so that's how we evaluate expressions. Now real quick, just to kind of run through a couple questions just before we begin, let's just kind of review some concepts that we've done in the past. Okay, here is some functions. So I'm asking, are these functions? Right? Well, this one right here, if you'll notice, the two 3's, they repeat in the x's, so this one is not a function. Right? Now, this one down here, D. Well, if you'll notice on this one, we've got unique x values. They all are unique. They're all different. Okay? And they all have a different output. And now you'll notice that these two have the same output, but that's perfectly fine. So this one, yes, it's a function. Right? Okay, this one over here, is it a function? Well, if it's a graph, we do the vertical line test. Okay, if a vertical line that we draw will hit the graph in more than one point, it's not a function. So this one is a no. So the only one that's a function is this one right here. Right? Now I want to look at two star questions real fast that are talking about slope and y-intercept. Okay, so here is the first one. It says a water hose discharges water at a rate of 45 gallons per minute. Which graph has a slope that best represents this line? Well, based on what we just learned about one of these questions with slope back here in the very beginning, on this one right here, okay, that we can have a graph that has a slope of 0. And a graph that has a slope of 0 is like this one right here. It has no slope. Okay, so we can automatically mark this problem out. Now what this one's looking for is, what is slope? Okay, and we know that in this problem it gave it to us as 45 gallons per minute. Okay, so that means that our slope is 45 over 1, because that's what the per minute is. So all I have to do is go to the graph and find out which one, whenever I do rise over run, up 45 over 1, does that hit the graph. So in this first one, okay, I come down here to a good point. I go up 45, I go over 1. Did it hit the graph? Yes, it did. Okay. On G, okay, when I go up 45 over 1, does it hit the graph? No, it doesn't. Okay, so this one is no good. Okay, when I go up 45 over 1 on this one, it just barely misses. It's close, but this one actually hits at 60. So this one doesn't work either. The only one that is correct is F. Okay, one more real fast. This one, it says, the table shows the number of gallons of gasoline in a car's gas tank after the car has been driven X miles. When these data are graphed on a coordinate grid, the points all lie on the same line. What are the slope and y-intercept of this line? Well, I've told you the way we do this is we always find the y-intercept first. And the y-intercept is the y value when x is 0. So our y-intercept is actually 15. So with that in mind, I can eliminate F and H in the answer choices, because it has to be 15. Now we got to find our slope. Okay? Our slope is going to be rise over run, or the pattern on the right, in this case, which is negative 0.4, okay, divided by the pattern on the left, which is 10. Now I'm hoping that a little common sense will kick in here. As this one says that our slope is going to be negative 0.4 divided by 10. Now when I type this into the calculator, am I going to get the same thing as 1 over 25? Or am I going to get 25 with both of them being negative? And this one, if you type it into the calculator, you actually get the same value as negative 1 over 25. And that is our answer. Now, let's begin our lesson. I know this one's kind of a long video. I apologize for that, but I wanted you to have the same thing that we actually did in class. So now, for proportional, okay, which is what this lesson is about, how do I determine if a function is proportional or not? So, if you look at this particular slide, we've got 4 graphs on the left-hand side that are all proportional, and 4 graphs on the right-hand side which are all non-proportional. What do you notice is common among the ones on the graph? Well, I'm hoping that you notice 2 things. Okay, you'll notice that each one of these graphs is a line. Okay, they are a line, they are linear, they have a constant rate of change. So what makes a graph proportional? The first thing is it's a constant rate of change. It is a line. The second thing is each one of these go through the origin. Okay? That's the second thing that makes a graph proportional, is it must go through the origin. So if you'll notice all these graphs over here, the first 2, they're lines, but neither one of them go through the origin. Okay? This third one here, it's got a curve. Okay? So it's definitely not a constant rate of change. And then this last one, it's got up change and down change and up change again, so it's not constant either. So that's what makes it non-proportional. Now what if we have an equation? In an equation, you'll notice all of these on the left are proportional. All of these on the right are non-proportional. I hope the thing that you notice is all the ones on the right that are non-proportional have a y-intercept. This has got a +2, this has got a -4. Now this one doesn't have a y-intercept, but it does have an exponent. And this one's got a y-intercept. All of these do not have a y-intercept, which means that it has a y-intercept of 0. Okay, so I don't mean to say that it doesn't have a y-intercept, because it does, because that's the point of intersection of the y-axis, and it intersects at the origin. So what makes the equation proportional? 1, it's a linear equation, and 2, the y-intercept is 0. The y-intercept is 0. Now, what I want to talk about on this, if you remember back at the very beginning of the lesson, we talked about this standard here, talking about y is equal to k over x, or kx, not k over x, but kx. Well, when we talk about a proportional relationship, that's what we're talking about. Y is equal to kx. We only have one number times x. And this k is represented by, or we say that it is a constant of proportionality. Okay? That's what this is referring to. So if our equation, okay, just has a number with a letter, okay, it has a y-intercept of 0, then the m in our typical formula, y equals mx plus b, is actually a k, and it is a constant of proportionality. But what you'll notice is that this constant of proportionality, it's the same thing in the same place as the m, which is a slope. But it's a constant of proportionality when I have a y-intercept of 0. Okay? So, that's how we determine whether or not it's proportional if it is an equation. One last thing. How could I determine if it is proportional if it's a t-chart? Well, there's 3 ways of telling that. 1, the t-chart must contain the origin, 0, 0. 2, the t-chart must have the same ratio throughout the whole table. Okay? So it's got to count by the same thing on both sides. And last but not least, it has to have a constant of proportionality. In other words, it's got to have a k value. Right? So if we look at this first one, it does have 0, 0 in the t-chart. It has the origin there. Now the only other thing is does it count by the same number? Okay, so we got a 9, and a 9, and a 9, and a 9. 1, 1, 1, 1. It does. So this one is proportional. Now you'll notice this t-chart, it doesn't have a 0 in it. Okay, so what we have to do is just go find it. Okay, so this one's 3, and it's counting by 1, so that means it's 2, 1, and 0. And then we just work this back up. Going down, it's counting by 4s. So going back up, we just subtract 4. So this will be 8, 4, and 0. And sure enough, there is the origin. Okay, now, one of these over here, if we take a look at this one, okay, this one we go find 0. It's just one place up. I'm counting by 2s going down, so I subtract 2 and I get 2. We don't have an origin. So this one is not proportional. So in order to determine whether or not a t-chart is proportional, is it must contain the origin 0, 0, and it has to have the same ratio throughout. Okay, so let's look at one or two of these real fast, and then we'll be finished. Okay, so if I ask you if this table, I give you this table and I ask you, is it proportional? We look at two things. First thing, if it's there, is does it have the origin? And it does. The second thing we look for is does it have a consistent pattern? 8, 8, 8, 1, 1, 1. It does. So this, yes, it is proportional. Now, if it is proportional, then it's going to have a rate of proportionality. And the rate of proportionality, when it asks you that, it's just asking you, what's the slope? So we look for the pattern on the right, the delta y, divided by the pattern on the left, delta x. 8 divided by 1 is 8, or 8 over 1. Right? Okay, so what about this t-chart? Right? Is it proportional? Well, we look for the same things. Okay, well, my 0, 0 is not there, so I look for the pattern first. So this is 6, 6, 6, 2, 2, 2. Looks good there. So now, does it have the 0 value in it? Well, I'm counting by 2s here, so let me count by 2s going back up. That's going to give me a -1 there. So we got to look at that 0 in the middle. So this one, if we count by 6s going down, I subtract 6 going up. So that'll be 6, and my 0 is actually paired with the -1. So this one is, no, it's not proportional. So if it's not proportional, it doesn't have a rate of proportionality. It will still have a slope, but it does not have a rate of proportionality. Okay, so 2 more questions, and then we'll be done. So this one right here. Which one of these graphs is not proportional? Well, we know for a graph to be proportional, it's got to go through the origin, and it has to be a straight line. So D is the one that's not proportional. Okay. What about this one? Okay. Well, again, which one's not proportional? Well, it's a line, it goes through the origin. Okay. It's a line, but it doesn't go through the origin. So this one is not proportional. One more t-chart. Well, I see one more here real quick. So what about an equation? Okay, remember an equation, for it to be proportional, it must have a y-intercept of 0. So it's got a y-intercept of something other than 0. So this one's not proportional. Each of the other 3 are. And now one more t-chart real fast, and then we'll be done, I promise. So what if I give you this t-chart and ask you, is it proportional or not? Well, again, we look for our 0 value. What it's looking like, it's counting by 2s here. This one looks like it's counting by 6. So I'll work it back up. Here's 0 right here. I go back up and look at there. I go back up 0.6 and it's 0. So we've got the 0, 0. So that's good. But now we have to look, is it consistent all the way down? So this is 0.6, 0.6. But this one right here is, this one is only 0.4. Not 0.6, and then it's 0.8 here. So this side is not consistent. So this is not proportional. Now I know this was kind of a long lesson. I apologize for that, but I hope you learned a little something about it.